right, today's topic are circuits, electric circuits. We're going to be looking at simple DC circuits. And this is a diagram of the most basic kind of circuit you can have. Um, Here's a circuit board with all kinds of devices that use current, and these are all resistors that control the amount of current to each of these devices. Um, so we're going to be kind of breaking things down in terms of the flow of current through a circuit. So what constitutes a circuit? So it's basically just a path for electric charge to flow, and if you remember, the flow of charge is called current. So in order for a circuit to exist, there has to be a complete path for the current to flow through, not to. In other words, you can't have a one-way street and have a circuit. So if the three parts of the circuit are voltage, you need a voltage source. Remember, that provides the push for the current. It's electrical pressure. You need a wire for the current to flow through, and then you need a resistor for the current to flow through. So it has to flow from one end of the voltage source through the wire to the resistor and then back to the voltage source. And remember, there has to be a potential difference across the voltage source in order for there to be a current. Okay, so the lab you're going to be doing, you're going to be hooking up a bulb to a battery using a single wire. And most people don't fully realize how a light bulb is put together. This is a Thomas Edison generation light bulb, which should be called a heat bulb. The current flows in through the base of the bulb, up a wire to the filament, which is a super thin piece of wire. And then the resistance in that wire causes the wire to glow white hot, giving us the white light. Then it flows down through another wire to this conductor, which is the threads that you use to screw the bulb into. Okay, and then those two, this conductor and this conductor, are separated by this insulator. So the current has to flow through the bulb, not just to the bulb. Okay, so these are all setups that would not get a lit bulb because it's not a complete circuit. It needs to flow from the positive pole of the battery to the negative pole of the battery through the bulb. Okay, and thus a flashlight is set up in order for that to occur. Okay, there are different aspects to a circuit. Okay, and in a schematic, which is a line diagram of a circuit, this notation denotes a battery. The lines denote wire. An open switch means that the circuit is open or broken, so current cannot flow. And then a closed switch, a closed circuit, means that there is a complete circuit and current can flow. So they're kind of counterintuitive, but if you look at the diagram, they make sense. And then this squiggly line pattern shows a resistor, and it could be like a light bulb or any device that requires current to operate. So there are two basic types of circuits. One where the resistors are put in end to end with each other. They're in a single row. Okay, and any break along the circuit will open the circuit and cause the circuit to be broken, and current can no longer flow. So in a series circuit, if one of the light bulbs goes out, excuse me, then they all go out. So the electric current has a single pathway through the circuit, and the current flowing through each device is the same. So if you have a single bulb, the current would be higher than if you have two bulbs, because now the two bulbs have to share the same amount of current. And then if you put a third bulb in, then the current is even less, so the bulbs would not be as bright. So the total resistance is super simple. It's just equal to the sum of the individual resistances. Would that be resisti? Individual resistances along the path. Okay. So if you want to figure out the current, remember Ohm's law of E equals IR, so I equals V over R. So you would take the voltage divided by the resistance, the total resistance, which is just the sum of each of the individual resistances. So if we look at this circuit here, if each of these bulbs is a 12 ohm resistor, what would the current be? Well, we see it's a 9-volt battery, so we merely take that 9 volts and divide it by 12 plus 12 plus 12. Let me see, get my calculator out. 12 plus 12 plus 12 is 36. 9 divided by 36 is 1/4. So the current would be 0.25 amps. Okay. Now the other type of basic circuit is called a parallel circuit, where each resistance is, or excuse me, each resistor forms a separate branch to the voltage source. So they are parallel to each other. And if you look, you can draw a line from this resistor directly to the battery, and it does not affect the others. Okay, so the voltage stays the same. So if I had this bulb hooked up and put a second one in parallel, then the brightness of this bulb wouldn't affect this bulb and vice versa. And then you can keep adding bulbs and they stay the same brightness. So what do you think is happening in the overall current in these wires here? It's going up. Okay, so if you take one of these and unhook it or break the circuit, then it doesn't affect. Just as when you add more, it doesn't affect the brightness or the current. Okay, so the current passes more readily into the devices with a low resistance. So the amount of current in each branch is inversely proportional to the resistance of that branch. So the math for parallel circuits is a little trickier. So the total current is equal to the sum of the currents in each branch. And the number of parallel branches is increase, the overall resistance of the circuit decreases, which is kind of counterintuitive, but it'll make sense as we go along. Okay. So what is the overall current in this half of the circuit if all three 12 ohm bulbs are lit? Okay, so what we would do is we take, here's our equation. So here's an equation if you have two identical resistors in parallel with each other. This equation you can use for any number, and you need to use it if it's more than 2. So it's 1 over R EQ, which is the equivalent resistance or the overall resistance. It would be the resistance in these wires here, equals 1 over R1 plus 1 over R2 plus 1 over R3. So they're each 12 ohm resistors. So 1 over REQ equals 1 over 12 plus 1 over 12 plus 1 over 12 equals 3 over 12. So then to find REQ, we inverse both of them. So REQ equals 12 over 3, which is 4 ohms. And then if we want to find the current, I forgot to finish, the current would be V over R, which is 9 volts over 4. So what's that? A little over 2 amps, which is significantly more than a single bulb. Okay, so let's practice this a little bit. If we have two identical 8 ohm resistors in series, what would the overall resistance be? Let's see, 8 plus 8, 16 ohms. Okay, what about if we put them in parallel? 1 over R equals 1 over 8 plus 1 over 8. 1 over R equals 2 over 8. So R equals 8 over 2, which would be 4 ohms. Okay, so pretty simple. Okay, now what if there are two parallel resistors in series with another one? Well, the order of operations is you have to figure out this first and then you add it to this. So 1 over R equals 1 over 8 plus 1 over 8. 1 over R equals 2 over 8. So R equals 8 over 2. So it was simplified down to 4 ohms. And then 8 plus 4 is 12. Okay. Ooh, now we have two parallel resistors in series with this one. And then this part of the circuit is in parallel with this part. Okay. So first we have to solve this one, add it to this one, and then figure out what these two. Okay. So 1 over R equals 1 over 2 plus 1 over 2. So that's going to simplify down to 1 ohm. 2 plus 1 is 3. So that simplifies down to this. And then we take 1 over R equals 1 over 3 plus 1 over 3. So R equals 3 over 2, which is 1.5 ohms. Okay. Wow. So what do we do first? We have to simplify these two. 1 over R equals 1 over 8 plus 1 over 8. So R equals 8 over 1, or 8 over 2 rather, which would simplify down to 4. Then we have to simplify these two. So 10 plus 10 is 20. 16 plus 4 is 20. Now we simplify these two. Simplifies down to 10. Okay. Now, usually what you want to do when you're figuring out a schematic is you don't want to know necessarily the equivalent resistance. You want to know how much current would there be. Okay. Because how much current can affect how the circuit behaves, and it might lead to what's called an overloading of a circuit